wireless and wired transmission media. We'll see the wired transmission media, the wired, or we also say it as guided transmission media. When we speak, when we are speaking, then we are actually using the unguided media or the air to propagate our sound waves, and this guy listens. Now here we need some wire, we need some communication channel or the physical channel. That is why we call it as a wired transmission medium. So wired or guided transmission medium, this is going to physically connect two computers, and these data signal are going to get physically transferred from transmitting computer, this TX, to RX, means transmitting computer to the receiving computer, and there has to be a wired medium. And there are various wired transmission medium. Twisted pair cable is the basic one, and this is the common form of wiring you find in networks, especially in local area network. So it consists of two insulated wire, and they form a spiral pattern like this. Spiral pattern. This is in the form of double helix, and it's generally used for telephone communication in offices and also in modern Ethernet networks. Ethernet networks. This Ethernet and all which we are going to see, they are all IEEE standards. For telecommunication of telephonic communication, we have a VGM cable. So there are different type of twisted pair. For telephonic communication, we have VGM, that is the voice grade medium cable which is used. But for LAN application, because we know that we need higher quality cable, we use data grade medium, DGM. This is the figure, or this is how the twisted pair you can see. So the twisting of wires does what? First of all, there is always a noise. When you are talking to your friend and some other guy is talking maybe some 1 meter or 2 meter away from you, then he may be talking meaningful, but for you his voice is noise, because you are talking to your friend and you are getting disturbed by that. So that is noise. So in communication channel, the basic problem, or you can say basic scenario is created by noise. So the twisting of wires, this reduces the crosstalk. This is one kind of noise. So it reduces the crosstalk, which is actually the bleeding of signal. That is the losing of signal from one wire to another. So this crosstalk can corrupt your signal, actual signal, and also can cause various network errors. Apart from preventing the crosstalk, this twisting of pair in the helical form also protect the signal from any external interference which is going to affect both the wires. Also creates which can create unwanted signals we don't want. Our signal is like that. If some interference there, it may become like this, and we don't want that. The advantages of this kind of cabling or wired medium, that is, it is capable of carrying signal over long distance without amplification, but the distance is long, means apart from, if you take example of another wired medium, it is way less. It is simple, low weight, and easy to install, easy to maintain. And for speed up to say 10 Mbps, this is quite adequate and least expensive medium, where the distance between the node is, as I just suggested, it is relatively smaller. But the disadvantage is that it is going to pick noise signals. As I just suggested, it is going to pick noise signals very easily. And because the size is thin, it may break. There are chances of it may be breaking if man-handled. And it is unsuitable for broadband application. You see the data rate it provides. There are types of twisted pair cables. There are two types of twisted pair cables. First is STP, that is the shielded twisted pair. Then you have UTP, that is unshielded twisted pair. So the STP, this comes with a shielding of individual pair of wires, which further protects it from any noise, which namely the external interference and the crosstalk. But this STP is heavier and costlier than this UTP. UTP, this also requires, this STP also requires the grounding at both ends. We have seen about that. There is STP which has some advantage, but the some second face of the coin also.